Hello, my fourth graders. Welcome back. This is new chapter 6. We are going to learn in this chapter about factors, multiples, and patterns. All right, and our target is understand factors, multiples, and patterns. And please see these criteria. Okay. All right. Please read it. Okay, so this is our vocabulary. This is something that we know already. So review words are what? Factors and product. So let's complete the graphic organizer here. Numbers that are multiplied together, what? Yes, numbers, when you multiply two numbers together, you can get what? Product. Yes. So the factors are what? Factors are the numbers that are multiplied to get a product. So for example, 2 times 4 is what? 8. So 2, this is factor. And 2 and 4 is also factor. And 2 together, they are we call factors. And what is 8? What is it? Yes, this is the product. So let's find out what times 1 makes 18. It can be different, right? So it can be 1 and 18, and 2 and 9, and 3 times 6 is also 18, right? So you can move on, but I'm going to pause in there. All right, let's move on to next one. It can be 1 and 24. Since this is even number, it can be what? 2 times 12, okay? And also 3 times 8 and 4 times 6. Okay, now I want you to find out this one. Okay, so use your vocabulary cards to identify the word. Find the word in the word search. Okay, so I'm gonna leave in for you. Let's move on to our lesson 1. Understand factors. Okay, so draw two different rectangles that each have an area of 24 square units. So label their side lengths. Okay, so you need to have what? 24 square units in the rectangle. So simplest one is what? I'm going to use 1 times 24. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, it was long. Okay, so this can be one option, right? 1 times 24. And you have what? 24 unit squares inside. And they were asking us to draw two different ones. So I'm going to go for 2 times 12. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 times 12, we know what? Yes, 24. 24 square units are going to be inside. Now compare your rectangles, okay, to your partners. Okay, it's fine. Okay, how is each side length related to 24? Yes, we can say each side length, which is like 1 and 2, 24, 12, those are what? The factors of 24. Okay, so we are going to move on and practice more to find out the factors. Okay, so now here you can write whole numbers as products of two factors. So when we have product, this is the what? Answer of multiplication, right? And the numbers that you need to multiply together, those two numbers we call what? Factors, okay? And then two factors are called what? As a factor pair, okay, for the number. So please remember factor pair. All right, now we are going to move on. Example, find the factor pairs for 20. All right, now find the side lengths of as many different rectangles with an area of 20 square units as possible. So 1 times what? 20, of course, will make 20 square units, okay? And 2 times 10 will make Yes, 20 squares. And 4 times 5 will make what? Yes, 20 squares. So here, please take a look. A 4 times 5 rectangle has the same area as a what? 5 times 4 rectangle. Both give the factor pair 4 and 5. So you don't have to write down 4 and 5, 5 and 4. They are same, okay, when it comes to factors. Now the side lengths of each rectangle are a factor pair. So the factor pairs are 20. So the factor pairs for 20 are what? First we have what? 1 and 20, and 2 and 10, and 4 and 5. Make sense? We call these numbers, right? So this side, like column and row, those are what? Factors when it comes to factoring. Okay? So to find out the factor, we call it factoring. Okay? Factoring. Alright, so factors are what? Two numbers when you multiply. Okay? When you multiply two numbers, we call those two numbers factors. Okay? And then when you get the answer, we call what? Product. Remember that? Alright, now number 1, show and grow. Use the rectangles to find the factor pairs for 12. Of course, we have what? First one is 1 row of 12 columns. And 2 rows of what? 6. 1, 2, 3, 4, 5, 6. You see that? And 1, 2, 3 rows of 1, 2, 3, 4. 4. Okay? So you can say what? 1 and 12, 2 and 6, and 3 and 4. Okay? Now draw rectangles to find the factor pairs for 16. First of all, you need to do what? 1 times, right? That's the easiest one ever. Okay, now I'm going to count 16. This is 16. Okay, so that's what? 1 times 16 is also 16. And since this 16 is what? Yes, that is the even number, so I know I can divide by 2. 2 times what? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 2 times 8. That is also what? The factor. Okay, 2 factors, 8 and 2. Alright, next one is 3 times table has 16. No, that means what? You need to move on to 4. So now 1, 2, 3, 4 times 4, we know 2, 3, 4. This is what? Is also 16. So what are the factors here? I mean, factor pair, you can find out like 1 and 16, right? 2 and 8 and 4. No more, right? You cannot say like 4 and 4. Okay, so that means what? 1, 16, practice this way, right? And 2 and 8 and 4. Okay, there's no more. Alright, let's move on. Number 3. Okay, this is your turn now. I want you to pause your video, my video, and then you can solve the problems and find out how many factor pairs you can find, okay, for each numbers. And then you can unpause when you're done with number 3 and check your answer with mine, and then you can move on, okay? And we'll see. Draw rectangles to find the factor pairs for the number. Okay, since we know this 14, always 1 and the number itself. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, and then since I know this 14 is what? Yes, even number. So you can divide the number into 2. 1, 2, 3, 4, 5, 6, 7. I know 2 times 7 is 14. What about 3? No. 14 is not a multiple of 3. What about 4? No. 5? No. Okay, so maybe it has only what? 1 and 14 and 2 and 7. Okay? I don't need to put this n in here again. Okay, so let me erase this to make it clear. Alright, let's move on. Number 4. I know 1 times 15. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's 1 times 15 is what? Yes, 15 unit squares inside. Okay, so we found 1 and 15. I'm gonna write it now. What about 2? Yes, since this 15 is what? Not an even number, so 2 cannot be the factor of 15. What about 3? Yes, we know 3 times what? Yes, 5. 1, 2, 3, 4, 5. 3 times 5 is also 15. What about 4? No way. Okay, we have already 5, so we cannot move on more than 5, right? So we can find what? 3 and 5 also. Okay, so factors are what? Factors of 15 are 15 is yes, 1, 15, 3, and 5. Let's move on. Number 5. Find out 20, okay? So factor of 20. I'm going to start from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So all the way down. Okay, that's what? 1 and 20. And then I can move to 1 and 2. Since I know 20 is even number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is what? 2 times 10 is 20. Okay, I'm gonna write down in here. And then what else? 3 times? No. 4? Yes, 4 times what? 5. 1, 2, 3, 4, 5. 4 times 5. What about 5? Oh, since we have 5, so you don't have to go more than 5, right? Okay, so I found 1 and 20, 2 and 10, 4 and 5. Okay, number 18. I know 1 times 18 is 18, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Always, 1 and number itself is always factors, okay? Now, since this is what? Yes, even number. 2 times, I know, 9 is 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, what about 3 times table? Yes, 3 times what? 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. That's also what? 18, right? Okay, now, what about 4? 4 times table? No. What about 5? No. Okay, since we have 6 times here, 3 is 18, we don't have to go more than that. So I can say what? Fact pairs are 1 and 18, 2 and 9, and 3 and 6. Now let's find out the factor pairs for the number. Okay, 11. So let's find out 1 and 1 times 11. I know. What about 2 times something? No, this is odd number. What about 3? No. 4? No. 5? No. 6? No. So there is only what? 1 and 11, the number itself. Okay, what about number 9? Let's find out the factor. What times, okay, what 2 numbers multiplied by together can make 9? That's the factoring. Okay, so I know 1 times 9 is 9. What else? 2? No. 3? Yes. 3 times 3 is 9 too. So since I know 4, 5, 6 can't be, so I know 1 and 9 and 3. Okay, that's it. Alright, move on. 4, I know 1 times 4 is 4. 2 times 2 is 4. Nothing else, right? So 1 and 4. 2, and 2. That's it. Okay, now what about number 25? I know 1 times 25 is 25. What else? 2? No. 3? No. 4? No. 5? Yes. 5 times 5 is 25. So the factor pair is what? Yes, factor pairs are 1 and 25 and 5 times 5. So I'm gonna write just 5. Okay, that's it. So what about 10? I know 1 times 10 first, right? And then since this is even number, 2 times 5 is 10. What else? 3, 4, no, already 5, we have it. So 1 and 10, 2 and 5. That's it. 1 times 40, easy, right? Yes, 2 times 20 is 40. What about 3? No. 4? Yes, 4 times 10 is 40. What about 5? Yes, I know. Multiples of 5, right? 45 times 8 is 40. So these are what? Pairs. So I can say 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Okay, so four pairs. Now, use the word factor to explain one way that 2 and 6 are related. Use the word factor. Okay, so we have to use factor. And we need to explain one way that 2 and 6 are related. How? Yes, 2 times 3 makes 6. That means what? 2 is a factor of 6. That's it. All right, let's move on. Think and grow, modeling real life. Okay, so you want to organize 30 pictures into a rectangular array on a wall. How many different arrays can you make? All right, to find the number of arrays you can make, find the number of factor pairs for 30. Okay, so now let's find out. Easy peasy, right? 1 times 30 is what? 30. Let's check from 1 to go up. 2 times, since I know this 30 is even number, yes, 15 is what? 30. This is divide, okay? So 30 divided by 2 is what? 15. You can see that, right? That's why we learn division first. All right, next. 3 times I know 10 is what? Also 30. What about 4? No, 30 is not a multiple of 4. What about 5? Yes. 5 times 6 is what? 30. What about, oh, we have already 6. That means what? You don't have to go more than that. So there are how many factor pairs are there? 1, 2, 3, 4. 4 pairs, right? And then you can use each factor pair to make 2 arrays, which means what? 1, because we can say what? 1 row of 30 columns or 30 columns of 1. So each pair can make 2 arrays. Make sense? And this one too. 2 times 15 and 15 times 2. Okay, 2 rows of 15 or 15 rows of 2. Okay, make sense? So each factor can make what? 2 arrays. So there are what? 4 factors, and then there are 2 possibilities. Okay, so how many ways? Yes, 8 ways to organize the pictures in different arrays. All right. Now, a city mayor buys 27 solar panels. Circle this, 27 solar panels, okay? Now, she wants to organize the panels into a rectangular array. How many different arrays can she make? Now, they were asking us to find out what? The factors of 27. Because we are going to organize the panels into what? Rectangular shape, which means what? Yes, array, remember? Now, we know first, always 1 times 27, right? 1 times the number itself is going to make what? The number itself. So 1 is always a factor of any number. Remember, right? And 27 is not an even number, so 2 cannot be the factor. What about 3? Yes, we know 3 times 9 is 27. What about 4 times? No. Okay, what about 5 times? No. 6 times? No. 7 times? No. 8 times? No. Okay, so there are no more. So how many different arrays? Yes, each you can what? 2 pairs by 2 possibilities, which means what? 4 arrays. You understand that, right? Because 1 rows of 27, or you can make what? 27 rows of 1. So each pair has what? 2 possibilities. Make sense? Okay. And 3 rows of 9 or 9 rows of 3. All right, let's move on. Number 15. A store owner has 42 masks to hang in a rectangular array on a wall. The owner does not have room for more than 10 masks in each row or column. What are the possible numbers of masks the owner should hang in each row? Okay, they twisted it a little bit, but this is still simple. That means what? You can't have a factor greater than 10. Makes sense? Because you cannot display more than 10 masks, okay, in row or column. So let's find out first. 1 times 42 we know is going to make 42. Okay, that's the first pair. What about 2 times? Yes, of course, 2 times 21 is 42. Now what about 3? Yes, 3 42 divided by 3 is what? Yes, 3 times 10 is 30, and you have what? 12 left over. This is mental division, guys, okay? Listen. So 3 times 4 can make what? 12. There is no remainder, okay? So 3 times 14 is what? 42. Still, so far they are all what? Greater than 10, which means what? You cannot display that way. What about 4? 4 times table can make 42? No, because we know 4 times 10 is 40 and 2 is going to be remainder. So you cannot have remainder for factoring. What about 5? No. 6? Yes. 6 times 7 is what? 42. So found it. There you go. Okay, you can display by what? 6 or 7 masks. Okay, in each, like 7 rows of six column, or 6 columns of 6 rows of 7 column. Either way, it will be fine. Okay. All right, that was fun. Okay, now number 16. A teacher wants to set up a chair for each of the 48 students in chorus. He wants to set up the chairs in a rectangular array. This is the hint. Okay, a rectangular array. So we know we can divide. Okay, we can find out the factor pairs. Okay, now he can fit no more than 20 rows and no more than 30 chairs in each row. Okay, so 20 and 30. That's the maximum. Okay, and you need he need to set up what? He needs to set up 48 chairs. Okay, now he can find no more than 20 rows. Oh yeah, I read it. I'm sorry. Okay, last question. What are the possible numbers of rows that he could set up? Now let's find out the factors of 48, and then it shouldn't be greater than 20 or 30. Okay, so now let's go ahead. 1 times 48 is 48. What about 2 times? Yes, 48 can be divided by 2, which is what? 24 is 48. What about 3? Yes, we know 3 times 10 is what? 30. And then 18 is left over. We know 3 times 6 is what? 18. So that's going to be 16. If you get confused, do this way. 48 divide by 3 and find out another factor. Because since we know 3 times, this quotient is going to be this dividend. Okay, so now 3 can fit into 4 by 1. 3 take away 1, bring it down 8, and 6 times 3 is what? 18. Take away, nothing left behind, so 16. Okay, what about 4? Yes, we know 4 times 10 is what? 40, and 4 times 2 is 48. What about 6? 5, I skipped 5, sorry. But we know, 5, this 48 cannot be multiple of 5, right? Since this is what? Ending for one digit is what? 8, which is not 0 or 5. All right, now 6 times what? I know 6 times 8 is 48. What about 7? 7, no, 7 can't be. Okay, so now we have to find out what? No more than 20 rows. So look at this. You see that here? 16 is less than 20. Okay. All right. So the answer will be 2, 3, 4, 6. I'm gonna write down the least to greatest. 12 and 16. Okay. All right, that's it. What are the possible numbers of rows that he could set up? More than 20 rows. More than 30 chairs in each row. Okay. Oh. I'm sorry, my bad. What about 2 times 24? That's 2 rows of 24 chairs, right? In each row. So that's less than 20 rows and no more than 30 chairs. Yeah, so that's also possible. So I'm sorry, 2 and 24 chairs also can be. Because we know what? 2 rows of 24 chairs can fit in the room. Okay? All right. But this 24 cannot be the row. Oh, I think I made you complicated. I mean confused, right? Because the answer is, you know what? We can put this 22 and 24, but the last question, what are the possible numbers of rows? Right? So 2 can be rows, but 24 cannot be the row. You understand? So the answer will be what? 2, 3, 4, 8, 6, 8, 12, and 16. We cannot include this 24. Sorry, 24. I know 2 is the pair of 24, but 24 cannot meet the requirement. Okay? All right, that's it. So 2, 3, 4, 6, 8, 12, and 16. All right, that's it for my 4th graders. Thank you for joining, and I will see, your homework. What? Yes, your homework will be 265 and 266, okay? We'll see you tomorrow. Bye-bye.